Welcome. This is section 1.6 and 1.7 of Miss Quinn's geometry. And today we're going to talk about undefinable terms and talk about why they're undefinable. Our first undefinable terms for geometry are point, line, and plane. And that is because all of these terms, in order to define, end up utilizing circular reasoning. And we'll talk more about that tomorrow. But for now, let's look at some definitions. A figure is a set of points. The space of a geometry is all the set of points in the geometry. 3 or more points are collinear if and only if they are on the same line. And 4 or more points are coplanar if and only if they are on the same plane. Go ahead and write those down. Pause the video if needed. And let's talk about the point, line, plane postulate. The unique line assumption says through any 2 points there is exactly one line. For example, if I draw a point here and a point here, because lines are linear, they have to be straight. And so the only way to get a line through these 2 points is to take the straightest path. That means there's only going to be one of them. The unique number line assumption says that every line is a set of points that can be put into a one-to-one correspondence with the real numbers. That means for each and every real number, there is one and only one point that corresponds with it on the number line. For example there, if I draw a number line that we're used to, say -1, 0, 1, 2, you can see that for each point on my line, it's going to map to one and only one point in the real numbers. And there are other ways to write number lines, but remember there must be a one-to-one correspondence. All right, how about the point, line, plane postulate? We have a dimension assumption here. This is the last part of our postulate. Given a line and a plane, there is at least one point in the plane that is not on that line. So in other words, to have a plane, let's say I draw some line in it. If it's a plane, there is going to be some point over here that's not on that line. And given a plane in space, there's at least one point in that space that is not on the line. So for example, let's say I have some three-dimensional space out here. And inside it, I have some sort of plane. Oops. Let's make sure those lines connect. I have some sort of plane. You can see that there has to be some point in that space that is not on my plane. The line intersection theorem, we're going to walk through that proof together tomorrow. But it says that 2 different lines intersect in at most one point. We have the definition for parallel lines. Go ahead and write this one down. Lines are parallel if and only if they have no points in common. For tomorrow, I'd like you to go ahead and try to write the definition for a point. We already said that we technically can't without utilizing circular reasoning, defining a word with its own word. But I'd like you to give it a shot. See if you can come up with a definition for the word point without using words like spot or exact location or place. And then I would like to know if a number line could be coordinatized, I can't talk, coordinatized as shown below. All right, bring those 2 questions for me tomorrow and I'll see you then.